Okay. Need to read the question carefully, right? Then we can easily answer this. So this is actually 50 ohm. This is ohm. 50 ohm. Diagram is not clear. Like that, this is 150. This is also 150. This is also 50. Right? Ohm, 50 ohm. Right. In the circuit shown, the ammeter and voltmeter are ideal, and the internal resistance of the cell is negligible. Cell electromotive force of the cell is 5 voltage, and the internal resistance is 0. If voltmeter replaced by another ideal ammeter, this voltmeter is now replaced with another ideal ammeter. Ideal ammeter in the sense internal resistance is 0. Like that, ideal voltmeter in the sense internal resistance is infinity. Now, the reading of the ammeter, reading of this ammeter, the reading of that ammeter in the sense the ammeter connected between these two terminals, not this one, right? If the ammeter is an ideal ammeter, then resistance is 0. That means these two terminals X and Y are, right, we can assume these two terminals are connected with the zero resistance wire. Zero resistance wire. Now just have a look on this, right? If these two are connected with the zero resistance wire, right? Look at this. This is 50 ohm, 150 ohm. This is 150, and this is 50, right? X and Y are connected, we can assume as X and Y are connected with the zero resistance wire, right? That means potential at X and potential at Y are same. That means this 50 and 150 are parallel with these 2 points, right? Let's say this point as A and this is B. Between X and Y are same. So this 50 and 150 are parallel, right? Like that, this 150 and this 50 are parallel. So the equivalent resistance we can find, equivalent resistance. If two resistance are parallel, equivalent resistance are multiplication over summation. Multiplication 50 into 150 over summation is 200. So that will be 150 over 4, so 37.5. So in the upper part, right, we can assume a resistance of 37.5 ohm is there. Like that, in the lower part also 37.5 ohm is there, right? This is the terminal A, this is terminal B, right? Now, if we mark the current provided by the battery, right? This is the battery, 5 voltage battery, right? And internal resistance is 0. We can easily identify the current, right? Look at this. This resistance is 50 ohm. This is 150. So the ratio is 1:3. If 4I current is coming through the point A, then what will happen? Right? 3I will pass through this way AX, and I will pass through AY. By symmetric, right? If this is I, this is also I, right? Then this 3I is coming here now. At their junction X, 3I will, right, split into 2. I is passing through X to B, and X to Y, there's an ammeter, X to Y, 2I will pass, right? 2I will pass. So this 2I and this I, so 3I will pass through this 50 ohm. 3I and 4I will pass, right, in this direction, right? So the current is okay. We can find the current in the circuit. I is equal to total electromotive force over the resistance, total resistance. So the 4I is equal to electromotive force is 5, internal resistance is 0, total resistance in this network is 37.5 plus 37.5, that is 75. That will be 1 over 25. Therefore, I will be, right, we have to divide this by 4. This will be, this will be 1 over 15, right? So, I will be 1 over 60 ampere. Now, the question is, current pass through the ammeter, right? This ammeter, that is 2I. 2I is equal to 2 into 160, that will be 2 into 160, that will be 1 over 30 ampere, right? 1 over 30 ampere in the sense the fourth one. Simple question.